Hi friends, this is Naresh. In this class, I am going to explain about engineering mechanics. And today's topic is area moment of inertia of an Z section. Okay, in this class, I will explain how to determine the area moment of inertia as well as centroid or center of gravity of an Z section. Here I consider the three different shapes. Okay, first of all I will explain about this Z section, then after I will explain about this model, and finally I will explain about this one. Okay, here I consider three sections as three problems. I will explain separately one by one. Before going to the problems, first of all you have to know the fundamentals. Here this is a rectangle having base B and height D. Okay, D refers depth or height, B refers base or length. Here x axis and y axis are called reference axis, whereas gx and gy axis are called centroidal axis, where CZ is the centroid of a rectangle. The centroid of a rectangle lies where its diagonals meet to each other. Okay, the intersecting point of these two diagonals is centroid or center of gravity, that is CZ. The centroid lies at a distance of half of the base and half of the height, that is base by 2 and height by 2. Okay, the given rectangle is symmetric about horizontal and vertical axis. Therefore, the centroid lies at a distance of half of the base and half of the height. Okay, gx and gy axis are called centroidal axis because these two axes are passing through the centroid. Okay, therefore these two axes are called centroidal axis, and xx and y axis are called reference axis. This is origin. Okay, now the area of a rectangle A equal to base into depth, that is A equal to B into D, and IGX is the area moment of inertia about gx axis, that is about centroidal x axis. IGX equal to BDQ by 12. Similarly, IGY is the area moment of inertia about centroidal y axis. Okay, IGY equal to DBQ by 12. Okay, now for composite sections, XC and YC are the coordinates of the centroid, where XC is the distance of centroid from y axis. That means the horizontal distance between y axis and centroid CZ. Okay, the horizontal distance between centroid and y axis is called XC. Okay, similarly YC equal to the vertical distance between centroid and x axis. Okay, the vertical distance between centroid and x axis is called YC. For composite sections, I consider multiple areas. Okay, in this problems, for our problems we have to determine the area moment of inertia about reference axis, that is IXX and IYY. IXX, IYY are called area moment of inertia about reference axis. Okay, from parallax theorem. That means here XX axis and GX axis are parallel to each other. Similarly, GY axis and YY axis are parallel to each other. Therefore, Here I consider parallax theorem or transfer theorem. Area moment of inertia about x-axis axis, that is this reference axis, Ixx equal to Igx plus area into Yc minus Y1 whole square for section 1. For number of sections you have to repeat this one again. Similarly, area moment of inertia about y axis, about this vertical axis, Iyy equal to similar formula. Okay, these formulas are used in our problems, so you have to remember. Now coming to the model 1, that is a type 1 problem. Determine the area moment of inertia of an given z section. Okay, the question is determine the area moment of inertia of an given z section. The given z section consists of 3 rectangles. Okay, first of all you have to split up the given section into 3 rectangles. I consider bottom rectangle as section 1. It has dimensions base b1 equal to 100 mm. That is base b1 equal to 100. B refers base. And depth or height d1 equal to 20 mm. Okay, this is 20 mm, this is 100 mm. So b1 and d1 are the dimensions of a section 1. Now I consider the middle rectangle as section 2. Okay, from here to here I consider section 2. The height of a second section, that is a vertical rectangle, equal to 80 minus 20, that is 60. Height of a second rectangle equal to 60, and base of a second rectangle, that is b2 equal to 20. From here to here the base b2 equal to 20 mm, and height or depth from here to here the depth d2 equal to 60 mm. Okay, and I consider this top horizontal rectangle as section 3. Okay, having dimensions from here to here the base b3 equal to 120 mm, and depth d3 equal to 10 mm. Okay, depth or height equal to 10 mm, and base b3 equal to 120 mm. These are the dimensions. Now I consider the reference axis, that is x axis at the bottom edge and y axis at the left side edge. Okay, this is y axis, this is x axis. This intersecting point is called origin. Okay, now first of all you have to find the location of centroid for z section. Then after you will find the value of area moment of inertia. Now the area of a bottom rectangle A1 equal to base into depth, that is 100 by 20 is the area of a bottom rectangle, that is A1 equal to 2000 mm square. And A2 is the area of a second rectangle, A2 equal to base into depth, that is base equal to 20 and height equal to 60, that is 20 by 60 for area 2. Area 2 equal to 20 by 60 equal to 1200 mm square. And A3 is the area of a third rectangle, that is the top rectangle. Depth d3 equal to 10 mm and base 3 equal to 120 mm. Therefore A3 equal to 120 by 10. Base into depth equal to 120 by 10 equal to 1200 mm square. Okay, these are the individual areas. A1 is the area of a bottom rectangle, A2 is the area of a middle rectangle, A3 is the area of a top rectangle. Okay, now I consider the x-axis at the bottom edge and y-axis at the left side edge, and this is origin. Now I am drawing the diagonal lines to locate the individual centroids. Okay, the centroid of a rectangle lies at where its diagonals meet to each other. Therefore, the intersecting point is called centroid. So C1 is the centroid of a bottom rectangle. The C1 lies at a distance of x1 from y-axis equal to 100 plus b1 by 2, and y1 from x-axis, that is y1 equal to d1 by 2. From previous slides, the centroid of a rectangle lies at half of the base and half of the height. Therefore, this is centroid. From here to here you have to consider as half of the base, and from here to here you have to consider half of the height. Therefore, y1 equal to half of the height, that means d1 by 2 equal to 10 mm. Okay, from here to here you have to consider up to y-axis. Therefore, the gap is 100 mm plus half of the base. X1 equal to gap 100 mm plus half of the base, that is 100 plus b1 by 2 is the value of x1. Okay, similarly I am drawing the diagonal lines for second section. Okay, C2 is the centroid of a second rectangle at a distance of x2 from y-axis and y2 from x-axis. Okay, this is y2, this is x2. The horizontal distance between y-axis and centroid is called x2. X2 equal to gap, this is gap 100 mm plus half of the base, that is 100 plus b2 by 2. Okay, from here to here value is b2, so you have to consider half of the base, that is 10 mm. From here to here 10 mm plus 100 mm, that is 110. X2 equal to 110 mm. Now y2 equal to, from here to here the value is half of the height, and from here to here equal to height of the bottom section, that is d1. From here to here d1 plus half of the height d2 by 2. So y2 equal to d1 plus d2 by 2. Similarly, I am drawing the diagonal lines for third rectangle. C3 is the centroid of a third rectangle at a distance of x3 from y-axis and y3 from x-axis. Okay, the horizontal distance between centroid and y-axis is called x3. X3 equal to half of the base. There is no gap. Okay, no gap between the centroid and y-axis, so you have consider half of the base only. Now the vertical height or vertical distance between x-axis and centroid is called y3. Y3 equal to height of the bottom rectangle plus height of the second rectangle plus half of the height of third rectangle. So from here to here, okay, please listen carefully. From here to here the distance is half of the height, that is d3 by 2, and from here to here height is d2. From here to here height is d1. So the value of y3 equal to d1 plus d2 plus d3 by 2. Okay, from figure the values are x1 equal to 100 plus b1 by 2 equal to 150 mm. So b1 equal to 100, that is 100 by 2 equal to 50. 50 plus gap 100 mm, that is 150 mm, and y1 equal to half of the height, that is 10 mm, and x2 equal to 100 plus b2 by 2, that is 100 plus 20 by 2 equal to 110 mm, and x3 equal to base 3 by 2, that is 60 mm. Now y1 equal to d1 by 2, that is 10 mm, and y2 equal to d1 plus half of the height, d1 plus d2 by 2 equal to 50 mm, y3 equal to d1 plus d2 plus d3 by 2 equal to 85 mm. Now these are the section numbers. Section 1 as a bottom rectangle, section 2 is the middle rectangle, section 3 is the top rectangle. These are the dimensions, and these are the individual areas. These are the coordinates of individual centroids, IGX, IGY. I refers area moment of inertia. GX refers centroidal x-axis, whereas GY refers centroidal y-axis. Okay, so therefore IGX is the area moment of inertia about centroidal x-axis. IGY is the area moment of inertia about centroidal y-axis. From previous slides already we have discussed about basic formulas. So area moment of inertia about centroidal axis, that is IGX IGY equal to BD cube by 12 and DB cube by 12 for rectangle. Similarly, section 1, section 2, section 3 are rectangles. Therefore BD cube by 12, BD cube by 12, BD cube by 12 for IGX. Now DB cube by 12, DB cube by 12, DB cube by 12 for IGY. Okay, 1 suffix 1 refers section 1, that is bottom rectangle. Suffix 2 refers middle rectangle. Suffix 3 refers top rectangle, that is the third section. Okay, from basic formulas, xc is the distance of centroid or center of gravity from y-axis, and yc is the distance of centroid or center of gravity from x-axis. xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and answer is x equal to 114.54. okay, similarly yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, and the answer is 41.36 mm. Here xc yc are the coordinates of the centroid. Okay, here C1, C2, C3 are the individual centroids, whereas CZ is the centroid of an entire Z section. Okay, the centroid CZ lies at a distance of xc from y-axis and yc from x-axis. Okay, the horizontal distance between y-axis and centroid CZ is called xc, and the vertical distance between centroid and x-axis is called yc, and the answer is x equal to 114.54 mm and yc equal to 41.3 mm. okay, now coming to the area moment of inertias, already we have discussed about IGX and IGY. IGX means area moment of inertia about central axis. IGY means area moment of inertia about centroidal y-axis. But we have to find the value of area moment of inertia about reference axis, that is x-axis and y-axis. Okay, xc yc are the coordinates of centroids, and this is gx gy are the centroidal axis. These axes are passing through the centroid from parallax theorem. Parallax theorem means here gx and xx axis. Xx axis, this is gx axis parallel to each other, whereas gy axis and y axis parallel to each other. Therefore I consider the parallax theorem or transfer theorem for solving the area moment of inertia about reference axis. Ixx means area moment of inertia about base, that is xx axis, and Iyy is the area moment of inertia about side axis, that is y axis. Okay, from basic formulas, Ixx equal to Igx1 plus area 1 into yc minus y1 whole square plus Igx2 plus area 2 into yc minus y2 whole square plus Igx3 plus a3 into yc minus y3 whole square. Already we have discussed about Igx, the value of Igx equal to BD cube by 12. Okay, and area 1, area 2, area 3 are the individual areas, and yc is the centroid of a Z section, and y1, y2, y3 are the individual coordinates of centroids, and the answer is Ixx equal to 4778484.91 mm power 4. Similarly, for for Iyy equal to Igy1 plus area 1 xc minus x1 whole square, Igy2 plus area 2 xc minus x2 whole square, and Igy3 plus a3 into xc minus x3 whole square. And the answer is Iyy equal to 9185423.79 mm power 4. These two are the final values. Okay, xc, yc are the coordinates of centroid of z section, and ixx, iyy are the area moment of inertia about reference axis. Okay, now coming to the another model, that is also z section. Okay, here also we have to split up the given problem into three rectangles. Therefore I consider the bottom rectangle, that is 100 by 20, as section 1, that is base b1 equal to 100 mm and depth d1 equal to 20 mm. These are the dimensions of a bottom rectangle, and I consider the middle rectangle as a section 2, having dimensions base b2 equal to 20 mm and height d2 equal to 60 mm. Okay, I consider only from here to here only, that is 80 minus 20. From here to here total height is 80, but you have to consider from here to here, that is 60 mm. So d2 equals 60 mm. Now I consider the top rectangle as section 3, having dimensions base 3 equal to 120 mm and depth d3 equal to, this is d3 equal to 10 mm. Okay, now I consider the reference axis, x-axis at the bottom edge and y-axis at left side edge. This is origin. Okay, now coming to the individual areas. Area of a bottom rectangle, that is a1 equal to base into depth, that is a1 equal to b1 d1, 100 into 20 equal to 2000 mm square, that is the area of a bottom rectangle. Now a2 is the area of a middle rectangle, that is a2 equal to base 2 into depth d2, 20 by 60 equal to 1200 mm square for area 2. Now a3 is the area of a top rectangle, that is a3 equal to base 3 into depth d3. Now I consider the x-axis at the bottom edge and y-axis at the left side edge. Okay, this is origin. So the entire figure lies in first quadrant. Therefore the values of x and y are positive. Now I am drawing the diagonal lines to locate the individual centroids. C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis. Already we have discussed in previous slides the centroid of a triangle, the centroid of a rectangle lies at where its diagonals meet to each other. Therefore the intersecting point of these two diagonals is centroid. So C1 is the centroid of a bottom rectangle at a distance of half of the base and half of the height. Okay, similarly I am drawing the diagonal lines for section 2. C2 is the centroid of a second rectangle. The centroid lies at a distance of x2 from y-axis and y2 from x-axis. Here you have to consider the gap 80 mm plus half of the base, that is b2 by 2. So gap 80 mm plus b2 by 2 is the value of x2, and y2 equal to half of the height of a second rectangle plus height of a bottom rectangle, that is d1 plus d2 by 2. Okay, from here to here height is d1, and from here to here half of the height, that is d2 by 2. Okay, Now I am drawing the diagonal lines for a third section. Now C3 is the centroid of a third rectangle. It lies at a distance of x3 from y-axis, that is gap 80 mm plus half of the base. Okay, gap 80 mm plus b3 by 2 is the value of x3. Now y3, at a distance of y3 from x-axis, that is height of a bottom rectangle plus height of a second rectangle plus half of the height of a third rectangle, that is d1 plus d2 plus d3 by 2 is the value of y3. Now from diagram, x1 equal to base 1 by 2, x2 equal to 80 plus base by 2, and x3 equal to 80 plus base by 2. Now y1 equal to d1 by 2, y2 equal to d1 plus d2 by 2, y3 equal to d1 plus d2 plus d3 by 2. Okay, in next slide I have written these values in tabular form. So these are the section numbers. Section 1 as a bottom rectangle, section 2 as a middle rectangle, section 3 as a top rectangle. Okay, now these are the dimensions and these are the individual areas. X and y values are coordinates of the centroids. IGX, IGY are the area moment of inertia about centroidal x-axis and centroidal y-axis. For rectangle, IGX equal to BD cube by 12. Therefore, IGX1, IGX2, IGX3 are B into D cube by 12. Okay. Similarly, IGY1, IGY2, IGY3 are also DB cube by 12. Okay. Suffix 1 refers rectangle 1. Suffix 2 refers rectangle 2. Suffix 3 refers rectangle 3. Okay. That is suffix 1 for bottom rectangle, suffix 2 for middle rectangle, suffix 3 for top rectangle. Okay, from general expressions, xc is the distance of centroid from y-axis, and yc is the distance of centroid or center of gravity from x-axis. Now x equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and the answer is xc equal to 85.45 mm. Similarly, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay, answer is yc equal to 41.36. Okay, xc, yc are the coordinates of centroid of an Z section. Here x axis, this is a reference x axis, this is a reference y axis. C1 is the centroid of a bottom rectangle, C2 is the centroid of a second rectangle, C3 is the centroid of a top rectangle, where C1, C2, C3 are the individual centroids, whereas CZ is the centroid of an entire Z section. Okay, CZ is the centroid of an entire Z section at a distance of xc from y-axis and yc from x-axis. Okay, the horizontal distance between centroid and y-axis is called xc, and the vertical distance between centroid and x-axis is called yc. Okay, from previous slide already we have determined the value of xc and yc. This is the final position of a centroid. Okay, this is gx and gy are called centroidal axis. Okay, gx and gy axis are passing through the centroid. Therefore, these axes are called centroidal axis. Xx and yy axes are called reference axis. Now, from parallax theorem, Ixx equal to area moment of inertia about base, and Iyy is the area moment of inertia about yy axis. From formula, Ixx equal to 4778484.91. Substitute the values. In previous slide already we have written the values. From that values you will get the answer. Ixx equal to 4778484.91 mm power 4. Similarly, Iyy equal to 9255757 mm power 4. Okay, this is the final answer for model 2. Okay, model 2 problem. XCYC is the centroid of this Z section, and IXX, IYY are the area moment of inertia about reference axis for particular this section only. Now coming to the another model. This is also Z section. First of all, the given Z section is split up into 3 rectangles. I consider the bottom rectangle, that is from here to here only. Okay, from here to here only I consider as section 1, that is base 20 and height 80 mm only. Okay, that is base b1 equal to 20 mm and height equal to d1 equal to 80 mm. So from base to here. Okay, now I consider from here to here as section 2, that is base from here to here, base is 90 mm, 80 plus 10 90 mm, base b2 equal to 90 mm, and depth equal to 20 mm. Okay, base 2 equal to 90 mm and depth d2 equal to 20 mm. Okay, now I consider the third section from here to here, that is base 10 mm and height from here to here, height is 100 minus 20 equal to 80 mm. Okay, this is a third section, base b3 equal to 10 mm and d3 equal to 80 mm. Okay, and I consider the x-axis at the bottom edge and y-axis at the left side edge. This is origin. Now coming to the individual areas. Area of a bottom rectangle, that is a1 equal to base into depth, that is b1 into d1 equal to 20 into 80. A1 equal to 20 into 80 equal to 1600 mm square. And a2 is the area of a second rectangle, that is a2 equal to b2 into d2, that is 90 into 20 is the area of a second rectangle. A2 equal to 90 into 20 equal to 1800 mm square. Now a3 is the area of a top rectangle, that is a b3 into d3. A3 equal to b3 into d3, that is 10 by 80 is the area of a third rectangle, that is 800 mm square. These are the individual areas. Okay, now I consider x-axis and y-axis at the edges. Okay, now I am drawing the diagonal lines for locating the individual centroids. Okay, the centroid of a rectangle lies at where its diagonals meet to each other. Therefore, this is a centroid. The intersecting point is called centroid, that is a C1. C1 is the centroid of a bottom rectangle at a distance of x1. x1 from y-axis and y1 from x-axis. Okay, this is y1, this is x1. The horizontal distance between y-axis and centroid c1 is called x1. Okay, the value of x1 equal to, this is gap 70 mm plus half of the base, that is b1 by 2 equal to 10 mm, 10 mm plus gap 70, so therefore x1 equal to 80 mm. Okay, y1 is equal to half of the height, that is d1 by 2, d1 by 2 equal to 40 mm. Okay, now similarly I am drawing the diagonal lines for section 2. C2 is the area of a second rectangle at a distance of x2 from y-axis and y2 from x-axis. Okay, the horizontal distance between C2 and y-axis is called x2. Okay, there is no gap between C2 and y-axis, therefore x2 equal to base by 2, base by 2, that is base 2 equal to 90, 90 by 2 equal to 45 mm. So x2 equal to 45 mm and y2 equal to height of the bottom rectangle plus half of the height of a second rectangle, that is d1 from here to here, d1 plus d2 by 2. Okay, y2 equal to d1 plus d2 by 2. And similarly I am drawing the diagonal lines for third section. So C3 is the centroid of a third section. It lies at a distance of x3 from here to here, the distance is x3 from y-axis and y3 from x-axis. Okay, the horizontal distance between centroid C3 and y-axis is called x3, that is base 3 by 2, that is 10 by 2 equal to 5 mm, x3 equal to 5 mm, and the vertical distance between centroid and x-axis is called y. So y3 equal to d1 height of the bottom rectangle plus height of the second rectangle plus half of the height of third rectangle, that is d1 plus d2 plus d3 by 2. Okay, now from figure x1 equal to 80 mm, this is from here to here the x value is x1 equal to 70 mm plus b1 by 2 equal to 80 mm, and x2 from here to here the value is x2 equal to base 2 by 2, and from here to here the value is x3 equal to base 3 by 2 equal to 5 mm, and y1 equal to from here to here half of the height, that is d1 by 2 equal to 40 mm, and y2 equal to d1 plus d2 by 2 90 mm, and y3 equal to d1 plus d2 plus d3 by 2 equal to 140 mm. Now these are the section numbers. Section 1 as bottom rectangle, section 2 is a middle rectangle, section 3 is a top rectangle. These are the dimensions, these are the individual areas. X and y values are coordinates of centroids. Okay, igx, igy are the area moment of inertia about centroidal axis. Okay, from basic principles, x is the distance of centroid from y axis and yc is the distance of centroid from xx axis. xc equal to 50.7171 and yc equal to 80.47 mm. Okay, now c1, c2, c3 are the individual centroids, whereas cz is the centroid of an entire composite section. Okay, CZ is the centroid of an Z section at a distance of XC from y-axis and YC from x-axis. Okay, the horizontal distance between centroid and y-axis is called XC, and the vertical distance between centroid and x-axis is called YC. Okay, X equal to 50.71 and YC equal to 80.47 mm. Okay. This is CZ is the final position of a centroid. From parallax theorem, you have to find the values of area moment of inertia about reference axis, that is the x-axis and y axis. Ixx is the area moment of inertia about xx axis, and Iyy is the area moment of inertia about yy axis. Okay, this is xx axis, this is yy axis, and Ixx equal to Igx1 plus A1 Yc minus Y1 whole square plus Igx2 plus Area 2 Yc minus Y2 whole square plus Igx3 plus Area 3 into Yc minus Y3 whole square. And the final answer is Ixx equal to 6959047.77 mm power 4. Okay, this is the value of area moment of inertia about reference base axis. Okay, similarly Iyy equal to 4377857.21 mm power 4. Okay, Iyy is the value of area moment of inertia about yy axis. Okay, xc yc are the coordinates of centroids, and ixx iyy are the area moment of inertia about reference axis. Okay, thank you.